Okay, so to add to the results of the turbine test, I went from 20 psi down to around 100 to 110 psi, and these are my results right here. And what's interesting is some of them do come to other people's types of results, or maybe a little different on the RPMs, but there's some type of resonant effect at some of the points. So the way I determined the sound, the frequency is by the sound. So I could hear the tone. I compared it to a tone generator on the internet, and by tuning to the tones that I heard on my test video, and also on videos on like YouTube on the turbines, I was able to actually find the RPMs. So it was basically the hertz or the frequency tone that you hear times 60 seconds, and then that equals the RPM, obviously. So, and then just to compare that what I was doing was correct, I listened to I looked at the tachometer on some of the turbine videos, and when I multiplied out, it was about the same. A good example I compared against was the YouTube engineer one. So anyway, so yeah, listen by ear and tune to the online tone generator to my video as well as other Tesla turbine videos. Then I multiplied the hertz by 60 seconds and got the theoretical RPM. This was close to the tachometer readings on some of the videos. So there's a effect where people are saying where the turbine jumps, and you can hear it too. The best one that I saw was the YouTube engineer video on the Tesla turbine, and their turbine jumps approximately 20,000 RPMs in seconds. So it goes from about 50,000 RPMs to 70,000 RPMs in almost like a second. So as I was doing my own test, I was looking for this effect too. I didn't notice it first, but when I reviewed my video, I actually had the same effect. You know, the RPMs are probably a little different, but there was some type of multiplication after a certain PSI. So I reviewed my video and also can show this around 60 to 70 PSI. There was some sort of resonance. So also you could even see on the plastic covering that this vortex pattern looked a little tighter. And so my around from 60 psi to 70 psi, it went from 63,240 RPMs to 80,460. So it had a 20,000 degree difference versus other parts on the list. So just as an example, at the 20 psi, you can see over here, so it was 22,000 about, then up to 32, 42, pretty much following the pressures too, which is an interesting thing to look at. So for 20, it was around, so for 20 psi, you get around 20,000, 30 psi, you get around 30,000, 40 psi, you get 40,000, 50, it's pretty much almost 50,000, 48,000 here. When you start hitting, even here, it looks like it's starting to resonate because it's going 20,000 about here as well. But anyway, so 40 to 50 to 60 here, and then 60 to 70 to 80, around 60 to 70 psi, and then again it starts slowing down slightly. So instead of going 10,000ths place, you're only going about a few thousand, and then again, so it was like so again at 70 psi it started slowing down again. So 80,000 it went to 83,000 at I'm sorry, at 80 psi went to 83,000. At 90 psi I went to 90,000 about. And then when I got to around 100 psi, it was at 95,100. And it was between 100 and 110 psi. But my false bearing, if you look in the video, it kind of flew off the center shaft. It wasn't fast or anything, but I didn't want to hurt the acrylic turbine. So yeah, and then when I took the turbine apart, which I'll show you again, I cleaned out and just put a new face on it pretty much so that you can kind of see a little better. But the turbine disc was intact, and that was pretty much it. I cleaned it out a little just so you can see through it. And yeah, so that's pretty much the test. So I guess scientifically, going from what other people did or what they found was the 20,000 hertz, 20,000 RPM increase. In a second, I had a similar result in my own. In the video I'm comparing mine to is they have it's about an inch diameter turbine, and mine's 2 inches. So it's like, I would think the hertz and stuff would be a little different for the resonance. So, and there is kind of a slight difference here. What I'm going to try to do is make a really nice, pristine turbine. I mean, this was my workhorse. I kind of, blasted it till things started to destruct. So, you can see there's like wear and tear on this thing. It's probably hard to see in the video. I'm going to do one that's nice and clean, maybe make a nicer bearing format. And then test it like really perfect. Like I'll even go through like maybe 5 increments if I can, and then give it more exact, like what the exact resonance of this disc is. Towards the 90 to 100 psi, there's something that I'm starting to sense here, and just like all the Tesla systems, you got the resonant frequency, and then you got harmonic frequencies. And just all that means is you have, the base frequency where the energy is really efficient at either moving through something. And then you have harmonics, which are usually also efficient areas where energy can be moved or is generating. So I almost felt like, first harmonic is, the first frequency is here. And then the first harmonic was probably around, it'd be above the 100 PSI mark. But again, that might be just an error. So it was kind of interesting that it seemed like something was starting to change here. Let's see, what else can I say? So yeah, that's pretty much it. I also, I don't know, I just wanted to, I'll show you that one more time. I guess I'll do one more video of just human powered turbine.